suppose so.
Yeah. Okay, we're ready to go.
All right, everybody. Welcome to the last seminar in our spring series. Just a quick reminder to the students that take the class that there is a report that you need to submit before the end of the semester. But that's sort of a detail. The important thing, this is a seminar that is jointly sponsored with the JetPerfect Foundation.
Thank you, Thomas.
Mr. Sorabo, who's here actually, the chairman of the foundation. Great pleasure to introduce our speaker today. Kevin Nordker is a entrepreneur and an engineer at the same time. Got his degree, undergraduate degree from Caltech in chemical engineering, and then he went to work while he was there. He was working as a good aerospace person at JPL next door in Pasadena. Went on from there to Northrop. He spent 7 years working in the defense sector, and then he transitioned from that to aerospace, the aerospace sort of smaller company, startup company world, where he co-founded and is now the CEO of a very innovative company in the electric aviation world. And it's a tremendous pleasure to have him on the Berkeley campus. And it is, by the way, his first visit to Berkeley. Kevin, thank you very much.
Thank you. Yeah, really good to be here. I had a few minutes before, between when I arrived and when we first were going to meet, and wandered the campus, and I was taken back to when I was about 17 years old, thinking about where I wanted to go to school. I'd been asked a bunch of questions. You want to go to a private school, public school, big, small? I had no idea. I just wanted a rigorous education. But I did have this picture in my mind of rolling grassy knolls and studying, and the dogs running around, and I didn't know at the time I was thinking about Berkeley, but now 20 years later I realized that in fact this is exactly what I had in mind, though I certainly loved my role back at Caltech. What a cool spot, and what a cool campus, and what a great education, and surrounded with really amazing people. So it's a pleasure to be invited and to be in such good company. So, you know, I know you see we've got maybe 45 minutes here. So what do we want you to walk away with in 45 minutes? I mean, you've spent years of your life already getting here, and you've spent many years and a lot of hard nights working forward. So, so I think out of this, obviously, I hope that you get some context for innovation in aerospace and aviation and the work that I do. But I also hope that you get a little bit of context about how you might go about answering these big what-if questions in your life. The things that you dream about, from the seat that you have today, the saying, hey, I'm studying engineering, but what if I could do this in life? What if I could start a company? What would it be like if I worked at SpaceX? Should I work at an internship or go into a big organization, or maybe go get my PhD and then start an aerospace program? Like, there are so many open questions in life, and they all start with a dream. And so maybe you'll walk away with just one story, my story, about how I went from your seat into the place where I'm at in the industry today. So start very quickly with a bit of context about me. So grew up in Park City, Utah, ski town, beautiful place, starry nights. It is where I wanted to become an astronaut, is when you stare at the stars long enough. You start to, with crisp enough cold air in the morning, you start to fall in love with nature. When you're in the most beautiful mountains in the world, you want to protect that natural world around you. And it's really where my core, where I grew up. Went out to Pasadena, California, and got a very rigorous engineering degree from Caltech, where I learned two things. One, like first principles analysis and like fundamental understanding. Number two, humility, because I was always the dumbest one in the room. Like, there was always somebody so much smarter than me. And in that environment, I also learned how to be very at home in who I was and what I did bring that might not be, the best at multivariable calculus or like dog bone integrals in the complex plane. Not my thing, it turns out. But I was very good at seeing the big picture, about engaging with people who were phenomenally smart, and then aligning our incentives so that we could go achieve things greater than any one of us could achieve. And so that humility ultimately turns into confidence when you place it in the right direction. As Panos mentioned, I started my career at Northrop Grumman. So after doing research at NASA's Jet Propulsion Laboratory, Northrop invited me over to do stealth technology work. So think about the B-2, but 30 years more advanced, the types of making airplanes invisible. It was magical, and the kind of Arthur C. Clarke laws of technology, indistinguishable from magic because it is so advanced. I loved that. It was a great place to start, a lot of responsibility. But ultimately, I felt it was a little bit too niche and limiting to where I wanted to be, the impact that I wanted to create on the world. And after turning into a program manager and exposing myself to the space side of Northrop, I decided to start a company, which was 9 years ago that we started Ampere, and is still where I today am the co-founder and CEO. And so Ampere has a big vision for the future of aviation. The future of sustainable flight, and I've got some very strong opinions on how we're going to get there. And currently, the company has a good 9-year track record for executing on that. But it all starts with, the Simon Sinek, like the why. Like, why are you doing something? I think it's really important to find those core values in life, those things you're willing to commit yourself to in spite of the world pushing against you, because that's where you have the resiliency and the tenacity to actually get through the hard times. I believe in the positive impact of aviation, in the connectivity it brings to the world around us, the development, the economic impact, the societal impact of connecting the world, packages and people. But I also feel like aviation is lagging when it comes to positive impact on the environment. And in fact, though we're about 2.5% of global greenhouse gas emissions today, if nothing changes, we're on track to be 25% by 2050. That's just not acceptable. And I definitely dream big of a world in which aviation is able to bring all those positive benefits without the negative repercussions alongside it. And this is really where we've focused Ampere, is how do you establish and scale a sustainable solution for aviation in a way that's not asking for favors or premium payments for being green, but actually does it through really good business practices and great products. And so this is where we've established ourselves. And one of the first things we did as a company was we set a mission statement, where I'll spare you the full mission statement, but the 3 keywords there: trusted, practical, and compelling. About acting with humility, pragmatism, intentionality in the work that we do, and trying to drive a very big impact. And what you'll see as I describe the company is these threads of trusted, practical, and compelling permeating everything we do: the products we make, the approach we take, the decisions we make on a daily basis, the things we choose to do, the things we choose to not do. And it's really, really at its core. But first, I suppose, though it's my first time on campus, it's not Ampere's first time on campus. We do have a collaboration ongoing, actually currently ongoing, with Berkeley, funded by the Department of Energy's Advanced Research Projects Agency. And this is to build the lab built a flying capacitor, multi-level DC-DC converter, very advanced set of power electronics. And our role was to help increase the technology readiness level of this, take it from lab through flight. And if my computer is connected properly, we're going to spend just 2 minutes here watching a video of that project. Programs like this are really important for Ampere because as a leader in the industry, we really take seriously our role in advancing the state of the art for technology. So with our flying test bed, our Cessna Skymasters, they're reconfigurable. So we can rapidly introduce new technologies into those propulsion systems and allow the increased technology readiness level through demonstration, bringing tech from the lab all the way through flight. In this case, we've partnered with UCB looking at a DC-DC converter. Now, this converter enables us to condition the power on the airplane and actually provide lighter weight electronic systems across electrified aircraft. So these kinds of projects are really important for the industry and for Ampere. At the leading edge of aviation, we are taking electric vehicle technologies and applying them into aircraft in ways that they've never been used before. This comes with a lot of challenges. Some of those challenges are about bridging the gap between the state of the art and aviation flight ready. This is why it's so important for us to have a flying test bed where we've partnered with the Department of Energy, ARPA-E, in enabling new technologies to be flight tested through our system. Our aircraft is reconfigurable, so we're able to take, whether it's power electronics, batteries, motors, software systems, even de-icing systems on the wing, new technologies which are uniquely enabled by electric vehicle systems, and mature them across the board so that they can become ready for commercialization too. As Ampere looks at the future of aviation, we know that we're not going to be able to do it all on our own, and we need to build and support an ecosystem of innovators to come along with us. So we're excited that UCB was able to fly with us too. And so that's just one example of a project which we're very proud of. And this idea of partnering with the ecosystem, being part of it, is also part of why I'm excited to be here. It is about reinvesting our energy into the next generation of technologies, the next generation of the workforce, into the next generation of startup companies that are bringing new tech and solutions into the world. I think that everything we do is built in context, and the more we're able to interconnect and support, the better the world will be. So clearly, I think deeply and broadly about the future of flight, and a lot of people do. And many of my peers in the industry, some of which you may have even had the chance to meet, will agree on this idea of let's build a quieter, a cleaner, a more connected and lower cost future for aviation. It's like an amazing dream that a lot of people share. But the reality of the world is that we have some very real constraints that hold us back. So what's currently holding the industry back today? Well, there's some practical challenges. The airplanes, it's very challenging to design a brand new airplane, especially when there's a ton of uncertainty underneath it. The infrastructure for sustainable aviation, whether that's the electric charging grid, the chargers at airports, the hydrogen infrastructure, really hasn't proliferated yet. The energy supply, so sustainable aviation fuels are scarce. There aren't really much available. They're not produced at scale. Where they are produced, they're very expensive. Batteries are heavy. Hydrogen is complex to handle at airports. Then there are all these operational realities that our customers think about. So payload trade-offs, reserve requirements. So how much energy do you have to store for safety? Turnaround times. Hey, I gotta unpack the plane and get it back up in the air within 15 minutes. How do you charge? Flight into known icing, and then you look at the certification requirements. How do we know that things are going to be sufficiently safe that we'd put our friends and children on them? And so where are the regulations ready, where are they not? And then finally, what are the economic conditions? And flat out, if it's not economically compelling, it's not going to scale globally. So some people look at electrification as a silver bullet, but we really see it as a set of trade-offs and timelines which need to inform a strategy. And so I have very strong opinions on the right way to approach things, and I believe that it's important to prioritize what we can do today. It's important to ensure that that aligns with where the future is headed, and that you're building a bridge to that future, but that you're not so enamored with the vision that you forget about the pragmatic real world steps that have to happen now. So we look at the future, but are always focused on the next flyable, fundable, and certifiable step across all of the factors that you might optimize for. And that's exactly what we see with hybrid electric aviation. Hybrid electric, we're excited about it because it can apply across all types of planes. In small planes, it looks like propulsion. In big planes, it looks like onboard auxiliary power. In all of these cases, you're able to save a significant amount of fuel. Those are through the energy efficiency of the overall system and how it's operated on the aircraft. You're looking at 50 to 85% fuel savings. So it's transformative, especially given that fuel is airlines' single greatest expense. Now, in the long term, there's some really interesting efficiency that can come with new airplane designs. Distributed electric propulsion, vertical takeoff and landing, boundary layer ingestion, like a whole lot of exciting things that are uniquely enabled from a vehicle architecture once you get the propulsion right. When you get those efficiency gains, massive market expansion is possible. So lower cost leads to expanded opportunity. You can scale the market size, just kind of filling in the blank space of where it's not economical today. But then you can also help commercial aviation continue to grow in a world positive way. And so that plus the fact that there are no inherent limiters like poor economics or lack of infrastructure that hold back hybrids is why we're so excited about hybrid as the gateway technology for the future of electrification in the space. And like, I wish I came up with the idea myself. Like aviation is not the first mode of transportation to go hybrid first and then transition to electric. We saw this for the first decades of electric vehicles on the ground, starting with infrastructure independent Priuses and then scaling to other hybrids before you started to get, your Teslas and Rivians and others that are now more common. But still today, if you go to rural parts of fully industrialized countries like the United States, you still won't have a plug within 100 miles of you. And what that means is that there are continuing to be real markets and real need for fuel efficiency, but in the hybrid in the hybrid application. What's particularly exciting is that hybrids have been a gateway technology for the fully electric, whether it's the batteries, the power electronics, the motors, the software, the controls, or all of the built-in kind of infrastructure around an industry. So the supply chain, the regulatory approvals, the maintainers in our industry, the pilots, these things are the inertia which ultimately enable you to carry from hybrids into a future of fully electric or hydrogen or wherever the future might lead. So going one layer deeper here, not all hybrids are made the same. They're actually quite different architectures. And so it's overly simple to say, oh, hybrids are good, because they're a wide variety. And so I'm just gonna, because I think you might be interested in it, I'm going to go through a few different types of those hybrids, three in particular. So an independent parallel hybrid, an integrated parallel hybrid, and then a series hybrid. So independent parallel hybrid would be like you have two engines, one which is fully electric, one which is fully combustion. Our flying test bed, where we're able to like put kind of anything into the electric vehicle system without much safety of flight risk, is because we have a completely separate and independent parallel path for propulsion, which is a combustion engine which the plane will fly safely on. And so this is an interesting, almost like the base case of hybrid electric vehicle design, where you have one of one type and another propulsion of the other. But if you were to take those two systems and marry them together, now you have an integrated parallel hybrid where both systems are providing mechanical torque to the output of the system, in this case, turning propeller. But if you removed that propeller and just took that generator set, now you're actually able to use it as a producing electricity or electrons that then can flow and be distributed for a whole wide variety of applications, whether that's onboard power, or maybe it's your vertical takeoff and landing distributed electric propulsion, blown air over the wing, or a lot of interesting configurations with planes. And so when you're designing an airframe, and maybe someday someone in here will be looking at how, like, building or designing or doing the trades on a new aircraft type, you'll probably be doing a lot of systems engineering, looking at all the constraints and interfaces, and that all begins with what the mission is. Why am I doing this in the first place? Why should this plane even exist? To what is the ideal architecture for that system? It's an energy optimization over the use case. And then ultimately coming down to, each of these types of architectures is good for a different reason. Sometimes they're easy to retrofit into old planes, like how we're starting as a company. Other times they're great for distributed power. In certain cases, it's about a trade-off between the range that the plane can fly fully electric compared to the amount of fuel that it's burning with the hybrid system. So taking that now one layer even deeper for these different types of hybrid systems, I'm going to walk through some cartoons on real world projects and how their hybrid propulsion systems are architected. So the first is actually an Ampere product. This is our launch product. You saw it in some of those videos flying. It's an integrated parallel hybrid architecture. So what that means is we've got a jet fuel engine that directly drives the propeller and an electric motor that also is coupled to that propeller for mechanical output. So you can add mechanical torque to the system with either of the two. What that means is that we've got a modest sized battery pack, and how this system ultimately works is that when you're taxiing on the ground, it's going to be pretty quiet. You're going to go all electric. During takeoff, you're going to add power from both of these systems, the combustion providing this base load of power for the system and all that boost power coming from your electric vehicle system. Think about a race car going off the starting line or your hybrid coming off of a stoplight. That's really, electric machines are great at that torque and that power boost up front. And then during the balance of the flight, during that cruise phase, you actually, because you were able to tailor this combustion engine to be so fuel efficient just for cruise, not requiring the added power for takeoff out of the combustion, you're able to recover some of that base load of power to recharge the batteries during your cruise phase of flight, landing with a full battery pack, enabling a very rapid turnaround and a whole lot of utility while saving between 45 and 50% of fuel over the course of the operation. So that's what we're doing at Ampere, but it's not the only solution out there. So there's another company that's doing a primary electric with a series hybrid range extender feature. That company's named Heart. So they really are leaning heavy into the all electric operation and then saying, hey, we'll fall back on a range extender to give us a little extra power if we need to fly further. So what this looks like is a giant battery pack, fully that provides electricity to a motor or multiple motors that turn propellers directly. And there is a small combustion engine in there, but it's just used as a generator during the occasion that you need a little bit more power than the batteries can provide. So in this case, all of your nominal flight is spent, whether you're taxiing, taking off, or cruising, is spent fully electric. You're carrying that big battery, you ultimately deplete the battery. If you needed to go further, now you're using your generator to extend your range a little bit, and then you descend. Now the challenge that they run into, one is that those batteries are crazy heavy, very challenging to put them into planes. The other is that when you land, you need to refill the plane. And you need to refill it with electricity. That means you need charging infrastructure, grid upgrades. If you need to turn around quickly, you're looking at megawatt class charging infrastructure, which is a bit of it exists, but it's relatively challenging to get integrated at airports and ultimately adds a barrier to entry into adoption. The last hybrid architecture that I'll go through is a series hybrid enabling distributed electric propulsion. So this company's name is Electra Aero, and they have a clean sheet design plane, which has propellers all across the wing. It's very aerodynamically efficient if you can accelerate the air over the wing. And so they're able to take off and land from very short runways with this type of a feature. So what this looks like is a primary generator as your source of electricity with a little battery backup for when you need an extra boost, and that those provide electricity to the distributed propulsion units across the wing. And so during this, you always have that base load of power from your generator, though instead of providing mechanical output like it did in the integrated parallel, it's actually providing electrical output the entire time. During your takeoff phase, you need a little bit of extra boost, so maybe you're pulling from a battery pack there. And then during the balance of flight, maybe you're recharging that battery pack, landing with a full a full pack, but primarily using your generator for your series hybrid architecture. And then at the end of the day, this type of a plane might not need to plug in as well. So, so those are three out of, there are probably like 6 or 7 common architectures that you might see being used in aviation, mostly in concept. But one of the things I love about Ampere is we're far beyond concept. Like, we've been at it for nearly a decade now, and we're flying the world's largest fleet of hybrid planes. We've done these different iterations. We've explored these different options. And so now I'll deep dive some of the other factors very specifically to our product. Again, that integrated parallel hybrid. This is a turboprop engine replacement. So it's the first example that I walked through. You can see it here, both. We're an aerospace company, so in front of an American flag, and then also in the nose of our launch product, which is a Cessna Grand Caravan, which is a system that we've flown and which we're already operating. So, like, why do this? Why would our customers buy this system? Well, compared to the alternative which they fly today, when they burn half as much fuel, they triple their profitability. These are businesses that scrape by with small margins in their operations. They struggle to stay in business because of how volatile fuel prices are and how challenging it is to make ends meet as a small airline operator. And when they switch to our system, they triple their profitability. It is game-changing for them economically, setting aside the benefits for the world when you're burning half as much fuel. So then they compare us, well, it's not just against the original conventional Jet A engine. It's actually against all of these novel technologies which are coming out, and they're making a decision, do I go hybrid? Do I go hydrogen? Do I go all electric? And ultimately, that also comes down to them, not to a technology decision, though I love the technology myself. For them, it comes down to a decision on the underlying economics. Why go with one solution over another? And this has been really core to how we build the business, is optimizing for the full economic scope of impact on our customer, not just from how much electricity versus how much fuel, but looking at maintenance costs, looking at the vehicle cost. How much money did you pay to buy the plane, to buy the propulsion system, to upgrade the charging infrastructure, to source all of the fuels? And when you look at the relative impact, what they generally look at is their net income, but you can look at your total expense, your capital expense to buy the systems, or your cost per available seat mile. At the end of the day, we did the trades in order to choose what was most economically compelling and viable to our customers. But I also care deeply about sustainability, and some of our customers do as well, and they want to invest in sustainable aviation fuels. Sustainable aviation fuels are exciting, but they're a little expensive, and so while they might be zero or even negative emissions, they're hard to get, and you're paying an insane premium right now to get them. So what we're able to offer by burning half as much fuel is having the cost of the fuel price, and then ultimately enabling net zero operations where you're using sustainable aviation fuel and hybrid together at cost parity to what your original operating budget was. Safety is at the heart of aviation, and our customers and anyone who sets foot in an airplane, some people take for granted, but we really shouldn't take for granted just how safe airplanes are. It is 1,000 times safer to fly on a plane than to drive to the airport. And so the numbers play out that aviation safety is just is kind of second to none. And when integrating brand new technologies, that's a consistent expectation, that when you bring a new technology, it must be at least as safe as what was already there. And so this is really interesting from our standpoint, because as this integrated parallel hybrid, again, different than the other hybrid architectures, where you have that combustion engine underlying the system and actually providing a direct mechanical output to the propellers. If you had the whole electric system delete mid-flight, you're still able to fly home safely on that combustion engine. Now, that's almost like a letdown. You're like, but I want the electric to be more meaningful. But the electric gets you the opportunity to optimize that combustion engine alongside the electric boost and get this holistic savings. And it then gives you these layers of fault tolerance that were never possible in aviation before, which means that with this kind of a safety case, we can go to the regulatory bodies and show them that not only are we meeting the safety criteria that the original technology had, but by adding in the new stuff, the electric stuff, the things that they might be afraid of, we're actually increasing the level of safety. This gets deployed for millions of flight hours and miles, and then that ultimately turns into trust and data, which underpins every subsequent deployment of electric technology, not just in this first step of a hybrid where we were able to fall back on the combustion, but eventually when electric is your primary safety. I actually think the electric systems are going to be more safe than the combustion, but it has to be proven. And this is our chosen pathway, navigating all the constraints for proving it out faster than the rest of the world, building our place in the industry and market, and then enabling us to then deploy the next generation of technologies thereafter. So this is what we do. I think it's a great way to be spending my life, building these systems that support better economics and growth in an industry, bringing new technologies, solving audacious challenges that are sufficiently advanced to be indistinguishable from magic, and building a capability that's quite exciting for the future. So a few places that we've taken this technology so far. So we've flown 30,000, I think it's like 33,000 miles so far, hundreds of miles of hours flown, demonstrated all the savings. Longest flight was like 1,400 miles, 12 hours. So I'll just highlight a few of the places where we've flown these planes. So the first one of my favorites, is Maui. So in 2020, we deployed on what's called an essential air service route. This community in Maui called Hana is served by government subsidized flights that provide essential goods. This is how doctors get out there. This is how critical supplies are moved. If you've ever been to Maui, people might say, hey, drive the road to Hana. It's beautiful, lots of waterfalls. It takes about 2.5 hours, but only do it once. And then you just don't want to do it ever again. It's treacherous. And that flight, it only takes about 20 minutes. So you're saving so much time. But right now you're flying at somewhat of a premium. When you fly electric or hybrid electric, you're actually able to reduce the burden of those flights and increase the connectivity to communities like Hana that are around the world. So we've flown around the country. One of my favorite flights was when I flew up to Palo Alto in one of our hybrids, because, startup company, you got to raise money. So I was like, I'm going to drop into the airport at the end of the Sand Hill Road, which is where all the venture capital investors are, right? And so I tell them, hey, I'm flying into the airport right there in Palo Alto. And all these investors, you want to know what they said? We have an airport in Palo Alto? Like, no one knows. No one knew it. No one knows how many airports there are. There are thousands. There are 5,000 airports here in the United States. If you wanted to buy a ticket on a major airline, you'd maybe go to one of 150. Where else in the world is it okay to underutilize our infrastructure by 95%? It's just insane. Now, there's some really interesting research going on here around what are the repercussions if you really start to use those airports in full capacity. And that there are these interesting plays on it, but people generally don't even know these airports exist. Yet we all live, I think 95% of the population lives within 20 minutes of these small airports. So they're very convenient. They're just unused and unknown. So we try to fly to a lot of those, whether it's flying over to Oshkosh to be featured in the air show there. We flew up with some international approvals through Canada, landed in Fairbanks, Alaska. That was an adventure. We had to turn around because of rain and fly another 300 miles to land back in Canada one time. Just, you learn a lot when you put yourself in the rugged reality of the world. And then we also had the opportunity to fly out in the UK, the Orkney Islands up in Scotland, and fly from the northernmost point to the southernmost point of the UK. And so this is just the beginning of where I see the industry and where we see the company going. Our goals coming up soon are to deliver the world's first commercial hybrid electric propulsion systems to support widespread adoption of electrification, starting as hybrids, but then going elsewhere, to lay this foundation for the future of growth in the industry. I think big dreams are valid. I dream big dreams. I ask what if, but I also think that you need to have a plan that's actually executable in the interim, and that it's a journey, not just one big leap. So in the last few minutes that I have here, I'm just going to zoom out a little bit. Went through a bit of my own background, talked a bit about the company, got into some technical details, talked about the optimizations that we made and why. There are decision points that we face through life. And this is like putting myself back 20 years ago when I was just entering school as somebody who kind of wanted to solve the theory of everything or maybe be an astronaut. And I was like, where am I going to go? I don't know. And so do I do physics or engineering? Do I do research or internships? Do I go into academia and get my PhD, or do I go into industry? Once in industry, it was, oh, do you want to be on the R&D team, which is cool technology but not implemented? Or do you want to be on the programs where you're actually working on the vehicles themselves, the end use products? Do you want to be an engineer, or do you want to be management, whatever that means? So do you want to turn into a leader, whatever that means? There are questions that you'll ask yourself over time. For me, it was, do I want to do airplanes or space stuff? Or what's next when, being at a big company wasn't filling my bucket? And then starting a company, like there's an infinite number of questions I have to ask myself every day. Down to like the staring at your hand, like, why am I here and what am I doing, to like what's really possible, like what's changing in the world around us, who cares about this, like why are we spending our time given the constraints, what can we really do, how do I prioritize those things, because you can do anything you want in life but you can't do everything. How do we get there once you choose where to go, and what are the resources you need, and just infinite more questions. So like you can't have answers to everything. So you need to have good principles by which you make decisions. Your good decisions won't always turn out right. You'll roll the dice, and even if you've weighted the dice in your favor, or your coin flips 60% in your favor, 40% of the time, it's going to be not in your favor. And you will then say, am I making bad decisions? I got it wrong. Well, if you're basing your decisions in life on good founding principles, then it's not a wrong decision, even if it didn't turn out the way you wanted it to. It's just the 40% that didn't play out, and that's expected in a stochastic type situation. So you have to have core values. These are some of mine. They're not yours. You can borrow them or use them. But the reality is it takes introspection along the way to figure out, what do I want to do? Who am I? What do I value? So for me, 3 guiding factors for me as an individual. I'm always looking for meaningful, challenging, visible work. We all have a very little bit of time here on Earth, and I'm going to have as big of a positive impact as I possibly can. It better be meaningful. Challenging, because I'm always up for a good challenge, but that's also how you find the limits of the possible. There's another great quote out there, like the way to find the limit of the possible is to dare to step into the realm of the impossible. And like pushing that boundary is how you actually learn where the boundary is. Most people live their lives in this like 35 to 55, 60% range, never daring to push to 110. And you have to find yourself happy to be uncomfortable, pushing just a bit into that challenging area. And then finally, visible, because it's hard to talk about invisible airplanes. You can't, there are things that I find that when things are visible, there's an accountability system that motivates me. When I know people care about the things I do, when they can see whether I succeed or fail, I'm more motivated to succeed. Second is I used to think I knew the path. Like I was gonna go to like these 10 jobs that were gonna get me to be the CEO of Northrop Grumman, and I had mapped the whole thing out like it was golden. And like the reality is, the moment you take a step, you're off the trail. And like in hiking and the backdoor, like outdoors stuff for me is pretty foundational. There are like 2 ways to do it. One is to have a trail map where you follow the trail, and the other is to do orienteering, off-trail navigation. Life is off-trail navigation. you're not following the beaten path. You have to find your way, and you do that with a compass, not with the trail map. And with a compass, you set your course. You say, I think I'm going to go this way for a bit. You go that way with conviction. You then stop, take a breath, you look around, you assess where you want to go next, and then you move with conviction in that other direction. This is orienteering. I'm absolutely an orienteer. I'm not a map maker. I don't know the future, but I know how I'm going to make the next few steps going forward. Next, I seek guidance all the time. I'm always asking people for their opinions. I love advice, but I take responsibility for my own decisions. Because if you don't take responsibility for your decision, and think of it like a Punnett square, like you took responsibility or you didn't take responsibility, it turned out well or it turned out poorly. In both cases, if somebody made the decision for you, like an advisor said, yes, you should go to this PhD program because my best friend runs it, like that might seem good, but if it turns out well, you're probably going to go back to that professor and say, what should I do next? And if it turns out poorly, you probably won't take full accountability for the decision because you're going to say they misled me. Whereas if you made the decision yourself and it turns out well, kudos, like awesome. Like it's always good when things turn out well. If it doesn't turn out well, at least you can make another decision because you've got a little bit of practice with it. And you can think through it and take ownership of those. And so the only way this plays out well, and it plays out actually well, either if it turned out in favor of you or out, is if you made those decisions on your own. And then finally, you see it in the values of Ampere, you see it in some of my own things: humility, integrity, pragmatism, a growth mindset, embracing change along the way, realizing that you have to iterate to get to where you want to go, that you only get there together by building connections between companies, peoples, building trust and collaborating. And with that, I've only covered a sliver, but I'm out of time. So thank you all very much.
For questions, so go right ahead. Questions. Yes.
Mentioned previously, you talked about how Ampere believes in reducing sound. What does Ampere do to reduce sound pollution?
Yeah, so there are a few ways to reduce sound or the noise signature of an airplane. Primarily, what you're hearing with propeller-driven planes is the tips of the planes shed vortices, and those are relatively loud. Like that, it's just like energy in air is sound. And so that violent moment where the air is kind of being split up there at the tip is the loudest part. So there are technologies for how to design a propeller that minimize the noise signature of that very specific portion. Second is an engine noise. Like my co-founder got excited about electric vehicles when he was an undergrad over at Stanford and nearly got run over by one of the world's first Teslas because he didn't hear it. And so when you get rid of the engine, there's an underlying noise signature that is reduced. Now, hybrid electric, we still have an engine, so we don't get the full benefit of that one. But in fully electric variants, they get phenomenal benefit from that. Those are the primary ones. There's a little bit of airframe noise. So think about driving your car down the road and then the whistling of air coming through the cracked window or off of the rear view mirrors. Same thing happens in airplanes, but that generally is a frequency of noise that doesn't make it down to the ground. But those are so propellers really is where we're focused, and then the longer term for electric is how we reduce the signature.
How did the weight of these hybrid planes compare to the traditional planes?
Yeah, so we add about 1,000 pounds of extra weight. And so that is really takes a lot of good engineering. One, to get it down so it's only 1,000 pounds extra. And two, to architect a system that, in spite of being heavier, still enables the end user to generate all of the revenue from passengers, like fill it up with passengers, fill it up with baggage, and don't lose any of the payload that mattered to them. And so while we add 1,000 pounds, you also fill it up with half as much fuel. In a lot of routes, you're actually kind of netting out only maybe 500 pounds heavier off the ground. And then when you look at how much weight these planes usually carry, like 2,500 pounds in our launch product, the Caravan, they usually had about 3,500 pounds of payload capability. And so that's taking a haircut, but we're holding sacred that payload that would have been filled with people or packages so that our customers can have all of the utility of the aircraft while still having lost a little bit of the headroom on weight.
Based off the models you've shown us of the hybrid aircrafts, which one would you say is the most sustainable and efficient for the future?
So I look at sustainability in a holistic sense. The plane that's going to be, or the architecture which is going to be the most sustainable, is going to be the one that at scale reduces fuel burn the most. Like that's the way I'll measure it, right? So there are that's not the same as a single unit which reduces fuel burn the most. So like a fully electric or sometimes hydrogen would be like zero emissions at the unit, right? And you would say, well, then that's the winner. But the reality is that where you can fly a fully electric, just like driving a fully electric car, where you can fly a fully electric plane, or worse yet, hydrogen, is phenomenally limited. And I think will be limited for a very long time. I think it'll be 100 to 1,000 times more limited than where the normal plane would be able to fly. And so when I am going to 1,000 times more destinations in my half fuel savings hybrid, then I'm 500 times more positive impact on fuel savings than if I was zero emissions, but on 1/1000th of the market, right? So I think to answer the question, the most sustainable is going to be the one that's full breadth, which has to be a plug-in optional, so it can't require the plug, and it's going to have to have the fuel savings, which the integrated parallel has the 50% fuel savings. The distributed electric propulsion one I showed, actually, the way at least Electra is doing it, they might not have any fuel savings. It's just performance improvement. And so, so integrated parallel hybrid for the foreseeable future, when batteries get better, increasing the share of electric and kind of eating into the combustion element. Eventually, there will be markets where fully electric makes sense, and that's what I believe.
And for one more question, yes.
So I was just wondering, like, for an Ampere, like, hybrid electric model, how much does it cost compared to a similar model that is conventional combustion, and how many flight hours does it take to make up that difference?
This sounds like one of my customers' questions. This is great because these are the factors that matter most when you're building a company. It's not just having a cool product, but having something that people are willing to buy in context of what their alternatives are. So for ours, the cost upfront, the ticket price, or like the sticker price to buy the engine, is the same as the combustion engine equivalent. And that's giving us pretty good margins as well. So if you're in market for a brand new airplane or a brand new engine, you buy ours or you buy theirs, no extra premium cost for ours. That's a really counterintuitive given where a lot of other sustainability technologies are. And it's really important from us being able to be competitive in the market. A lot of our customers already have engines though. And so they're retrofitting old planes. So how do you do that, right? They have a plane, they have an engine, and now I'm selling them this engine. Well, that looks like a net extra cost. Well, traditional engines go through a major overhaul cycle every few thousand hours, and those overhaul cycles cost, call it $500,000 a piece. If you saved that money and instead of overhauling that engine, you allocated it to the $1.25 million cost for our system, and then you took the engine, your old engine core, and sold that off into the secondhand market, call it another $500,000 value there. You net out at $1 million toward the purchase price of 1.25. And so you only have to make back a few $100,000. And in those cases, our customers, like the one I showed earlier, they're increasing profitability by $600,000 a year per unit. And so they pay it off in 6 months. Lower utilization, like some of the cargo folks, might take 2 years to pay it off. But that's kind of how our customers look at it.
Terrific. Well, thank you again.